voltage, A or B, in the parallel configuration?
They're the same.
Same, good. Same voltage dropped across, here and here. Which one has more current, or is it the same?
A has more current.
A has more current, so which one's brighter?
A.
A, good. For this configuration, which one was brighter?
B.
B. So the series configuration versus the parallel configuration was switched for which bulb was brighter. So if someone gives me two bulbs off the shelf and says which one's brighter, tells me the resistance, really my answer back should be, well, it depends. How are you connecting them? Because in one situation, one is brighter than the other. Last question here before I move on to chapter 4. Let me give you a minute, see if you can work this one out on your own. This is the same type of bulb. This is a bulb A type. This is a bulb A type. They both have the same 10 ohm resistance. I'm just going to call this, though, A1, and well, actually I'll call it AS and AP for A parallel and A series. I want you to tell me how much brighter A parallel is than A series. Like, is it twice as bright? Is it 4 times as bright? Is it 8 times as bright? Is it 50% as bright? So just take 2 minutes to try to work that one out on your own, pencil and paper, to tell me how many times brighter is A in parallel versus A in series. So now I'm not comparing A to B, I'm comparing AP's brightness to AS's brightness. Compare the two brightnesses. I have written down the brightness for bulb A in parallel, bulb A in series. In each case, the power is current times voltage. And I'm going to compare this with this. Now, I could put that into my calculator to get a number, put that into my calculator to get a number, look at the ratio. I can kind of skip that step, though, by just looking at the differences between these two. You can see they both have 120 squared in them. This is divided by 10. Let's see, this 10 divided by 10 plus 20 is the same thing as 1/3. 1/3 times 30 would be that over 90. Okay? So it looks like this is divided by 10, that's divided by 90. So this bulb would be 9 times brighter than that bulb. So bulb A connected in parallel would be 9 times brighter than bulb A connected in series. So again, that's not comparing A to B. That's comparing A from one configuration versus A in the other configuration. If I lost you a little bit here on this canceling out and skipping the calculator, no problem. You could just put it into your calculator and get it. James?
How'd you get I, like 120 over 30?
And
That's
this
just-
circuit here,
Yeah,
well, the total voltage is 120.
yeah.
That's 10 ohms. That's 20 ohms. So the combined is 30 ohms.
So you have to add them? Okay.
So I did 120 volts divided by the total resistance.
Oh,
So
the total.
120
Oh,
over
okay, okay, gotcha.
Okay. Is there anything in this analysis today that I did that's new? Is there anything here that was different than what we've done before that you didn't already have the tools to do? No, but it doesn't mean it's not worth doing. I mean, somebody could just tell you the fundamental theorem of calculus and the definition of a derivative and say that's it for calculus. But it takes a lot of time to go through different ways problems could be asked, etc. So I think it's worth going back and revisiting these, especially this one